Broccoli. Broccoli. Hey, hope you're having a good day. I really do. And don't forget to eat broccoli. It's good for you. Today we're going to talk about perimeter, circumference, and area. The perimeter of a polygon is the sum of the lengths of its sides. The area of a polygon is the number of square units it encloses. You can use formulas for perimeter or circumference of circles. You can also use formula for area and all that good stuff. Okay, so can we figure out a formula for the perimeter of a square? How about the perimeter is 4 times s, because there's 4 of those sides and they're all the same. And the area, length times width, is just s squared. Let's see, is there a formula for the perimeter of a rectangle? See, add up all the sides. There's 2 bases and 2 heights. So perimeter is 2 base plus 2 heights, or you can use the distributive property to write it as 2 times whoopsh, the base plus the height. And the area of a rectangle is the base times the height. How about with a triangle? Well, the perimeter is just going to be A plus B plus C, and the triangle's area is 1/2 the base times the height. And it's important to know that the base and the height have to be perpendicular to each other. You can't do like A times H, because H isn't perpendicular to A. Ooh, circle, maybe not so obvious as the square and the rectangle were. The circumference of a circle is pi times the diameter, or 2 times pi times the radius. The 2 because 2 times the radius equals the diameter. And the area of a circle is pi times the radius squared, pi r squared. So I would put these in your notes. I would commit these to memory. Actually, commit all these to memory. They're all pretty important. There. These you should memorize. This you should memorize. Perimeter, you can pretty much just add up the side lengths of any figure they give you. But these are important formulas to remember and to have in your notes. The Botany Club members are designing a rectangular garden for the courtyard of your school. How nice of the Botany Club members. They plan to place an edging on the outside of the path. On the outside here. How much edging material would they need? Okay, so it looks like the edging material is just outside here. On the outside of the path. Okay, well, we need to find the dimensions of the garden plus the path. So for a rectangle, length and width are often used instead of base and height. So the width of the garden and the path together is 4 plus 16 plus 4. That's 24 feet wide. The length of the garden is 4 feet for the walkway plus 22 feet for the garden plus 4 more feet for the walkway. So the length is 30. And now the perimeter tells us how many feet of border we would need to go around it. So that's just going to be 2 times the base plus 2 times the height. 2 times 24 plus 2 times 30. Simplify. 108 feet. You're going to need 108 feet of edging material. Alright, pause and see if you can figure out this question. Okay, welcome back. You want to frame a picture that is 5 inches by 7 inches with a 1 inch wide frame. So here's a picture that's 5 inches by 7 inches with a frame that's 1 inch wide. Alright, so we got 1 inch here, 7 inches there, and 1 inch there. So the total height is going to be 9. And then the total width is going to be 1 inch plus 5 inches plus 1 more inch. That is 7. So, now first, what's the perimeter of the picture? The perimeter of the picture is just the 5 by 7 part. So the perimeter of the picture is going to be 2 times 5 plus 2 times 7, which is 10 plus 14, and that is 24 inches. Now the perimeter of the outside edge of the frame is going to be 2 times 9 plus 2 times 7. That's 18 plus 14, and that is 32 inches. Chicken grease. Yep, chicken grease. That's the secret code phrase. Boom. Chicken grease. So, you can name a circle with the circle and a dot symbol. For example, the circle with center A is written circle A. The formulas for circle involve the special number pi. Pi is the ratio of any circle's circumference to diameter. Since pi is an irrational number, and it goes on forever, the terminating is a non-terminating decimal, for approximation you can use 3.14 or 22 divided by 7 or just the pi number. Your calculator probably has a pi button. You can use the pi key on your calculator to get like a nicely rounded answer for pi. For an exact answer, just leave it in terms of pi. For an exact answer, just leave it in terms of pi. Okay? Okay. What is the circumference of the circle in terms of pi? So we want an exact answer. So the circumference of circle M. Formula for circumference, given the diameter, is pi times the diameter. Pi times 15 is 15 pi. So the exact answer is 15 pi. The approximate answer is 47.1. How about circle T? So if we're given the radius, we use 2 pi r. 2 times pi times 4, that's 8 pi. The exact answer is 8 pi centimeters, approximately 25.1. Alright, pause. See if you can get A and B of number 2 here. Okay, so what is the circumference of a circle with a radius of 24 meters? So circumference is 2 pi r, 2 times pi times 24, and that is 48 pi. And B, what's the circumference of a circle with a diameter of 24 meters? In terms of diameter, circumference is pi d, which is pi times 24, and that is 24 pi. I wish I had 24 pi's. What is the perimeter of triangle EFG? Ooh, tricky. This is coordinate geometry. So we're going to have to use the distance formula. Haha. And then add them all up. So step 1 is find the length of each side. So for E and F, we can use the ruler postulate because it's straight up and down on the y-axis. So all we have to do is subtract the y values. 6 minus negative 2 is 8. Absolute value of 8 is 8. We can do something similar with FG. We can just subtract the x values. So the absolute value of 3 minus negative 3 is 6. Now for EG, we're going to need to use the distance formula. So the square root of the distance of the difference of the x values, so 3 minus negative 3 squared, that'll be 6 squared, And then 6 minus negative 2 will be 8 squared. 6 squared is 36. 8 squared is 34. That's 100. Square root of 100 is 10. So now to find the perimeter, we just need to add these together. Boom, 24. So the perimeter is 24 units. All right, let's pause and see if you can figure out number 3. Okay, so plot these points. It'll end up looking like this. And what is the perimeter? All right, let's see. Here we can use the ruler postulate. X values are the same, so we just need to subtract y values. 3 minus 1 is 2, so that's 2 units. We can use the ruler postulate on this one too. Notice the x values are the same. 4 minus negative 3 is 4 plus 3, so that is 7 units. We're going to have to use the distance formula for these two because they're not straight up and down or horizontal. So for the first one, I'm going to do difference of the x values, 1 minus negative 3, and then difference of the y values, 4 minus 3. Minus a negative 3 turns to plus 3, so that is 4 squared plus 4 minus 3 is 1, so 1 squared. 16 plus 1, so it's exactly square root of 17, which is approximately 4.1. Approximately 4.1. So this is about 4.1 units. Okay, so for the other slanted side, got to use the distance formula there too. Difference between the x values, negative 3 minus 1. Difference of the y values, 1 minus negative 3. So that's negative 3 minus 1 is negative 4. 1 minus negative 3 is 1 plus 3, so that's 4. Square root of 16 plus 16 is the square root of 32, which is approximately equal to 5 point, we would have to round up, so 5.7. Now the perimeter is the sum of all these sides, so we need to do 2 plus 7 plus 4.1 plus 5.7. And let's see, 2 plus 7 is 9. Plus 4 is 13.1. And if I add 5.7 to 13.1, I get 18.8 is the perimeter. Approximately, because we approximately 18.8 units. Because remember, we approximated here to get the 4.1 and the 5.7. Alright, you want to make a rectangular banner similar to this awesome banner. The banner shown here is 2.5 feet wide and 5 feet high. To the nearest square yard, how much material do you need? So, we need to convert our dimensions to yards because we want to know square yards. Because square yards is what they sell fabric in. So we know that 1 yard is 3 feet. So that's our conversion factor. So 2.5 feet is 5 over 2. So we're going to multiply times yards over feet. 5 times 1 is 5. 2 times 3 is 6. So that's 5/6 of a yard. 5 feet times 1 yard over 3 feet. The feet will cancel and we get 5 times 1 is 5. This is like 5 over 1. 1 times 3 is 3. So 5/3 of a yard. Now, we want to find the area. We want to know how much fabric there is up in here. So, find the area of the banner. Base times height. 5/6 times 5/3. That'll be 25 over 18, which is about 1 7/18. So, how many do you need to buy? You need to buy 2 square yards, because they're not going to sell you 1 7/18 of a square yard. You got to get 2 square yards, and you'll have a little left over. You can maybe make a scarf or something. It'll be nice. Just you wait and see. It'll be nice. All right, go ahead and pause and see if you can do number 4. Okay. How much paper do you need? You need to give your answer in square feet. Our poster is 3 yards wide, but we need to get this in feet. So how many feet per yard? There's 3 feet for 1 yard. We need yards on the bottom so that our yards will cancel. 3 times 3 is 9. 1 times 1 is 1. So we got 9 feet for the width. And 8 feet for the height. Area is base times height. Area of a rectangle, that is base times height. So this is 9 feet times 8 feet. And that is 72 square feet. What about the area of a circle? In terms of pi, so we want an exact answer. Well, first we need to find the radius, because the formula for area of a circle is A equals pi r squared. That's an r. Trust me. Alright, so if the diameter is 16 meters, the radius is half of that, so the radius is 8 meters. Now we're going to use the radius to find the area. Pi times 8 squared, so that's 64 pi. The area of circle K is 64 pi square meters. Alright, go ahead and pause. See if you can do number 5. Alright, so the diameter of a circle is 14 feet. That means that the radius is 7 feet. It's half the diameter. What is the area of the circle in terms of pi? Area equals pi r squared. So that'd be 7 feet squared. So 7 squared is 49. So we would have 49 pi square feet. B, what is the area of the circle using approximation of pi? Well, we can do 49 times, and then if you type P, pi will show up to a bunch of digits. And that equals 153.9, I'll round it to 94. 153.94. Square feet. Which approximation of pi did you use in part B? Well, I used the however many digits that is approximation of pi. 3.141592. That's a lot of digits. That's pretty accurate. More accurate than we can measure with a ruler, you know what I mean? What if we used 22 over 7? 3.1428 instead of 3.1415. So the most common one is just 3.14. But if you use the pi button, see, is there a pi button? Yeah, boom, pi button. you get a lot closer to the actual value. Even though you're still an approximation, you're pretty dang close to the actual value. Area addition postulate. The area of a region is the sum of the areas of its non-overlapping parts. So, what's the area of this here figure at the right? All angles are right angles, by the way. So we need to separate this figure into rectangles because we don't have a formula for the area of a B2 shape. But we do have formulas for area of rectangles and squares. So if I cut it here and cut it here, I will have 3 rectangles. And then, so the area of region 1, 3 times 3 is 9 square centimeters. The area of region 2 is 3 times 6, 18 square centimeters. And the area of region 3 would be 3 times 9, 27 square centimeters. Okay, there's all that. And then we need to add them all together to find the total area. So the total area is 54 square centimeters. Alright, so what's another way to separate the figure in problem 6? Well, we could have cut here and here, and we'd have had 2 little squares and 1 big square. So this would have been 3, and then this would have been 6. This would have been 3, this would have been 6. And then 3 times 3 is 9. 3 times 3 is 9. 6 times 6 is 36. And we could add those up and get 54. Alright, pause. See if you can figure out the area of this guy right here. Alright, so maybe you cut it up the same way I'm going to, maybe not. But since this segment is congruent to this segment, I know that this point is the same height as this point. So I can cut it right there and I'll have a rectangle and a triangle. My rectangle is 4 times 12. That's 48 square feet. My triangle, see, this is 4 feet also. So that means that this, from here to here, has to be 8 feet. Because 8 plus 4 is 12, and that's the whole distance there. So the area of my triangle is 1/2 the base times the height. So that is 1/2 of 32, which is 16. So this part here is 16 square feet. 16 plus 48, I'm adding the two areas together now, is 64 square feet. Look closely. These are cool beans. I'll see you later. Bye.